Okay, class, today we're going to discuss some of the things we've been having trouble with class and move forward on through to some more lessons, some new stuff that we can advance the class and get you ready for Organic 2. Okay, so we were talking about an alkane, 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 no double bonds, no unsaturation, and the general formula for an alkane is CnH2n plus 2. Okay, for example, let's say we had propane, it would be C5H12. Okay, pentane we know has 5 carbons. Okay, if we went to, and let's just draw a brief structure of that, which would be CH3, CH2, CH2, 1, 2, 3, CH2, CH3. Okay, 1, 2, 3, 4, 5. Okay, now if we were to talk about an alkene, and actually this is these are both acyclic. Okay, acyclic alkene. Okay, the formula for that, the general formula for that is CnH2n. If we stick with the same carbon 5, C5, the number of hydrogens would be 2 times 5 is 10, H10. Good structure example of that would be for an acyclic alkene would be CH3, CH2, CH2, CH double bond CH2. Okay, we got our 5 carbons and we got our 10 hydrogens. Okay, moving along. Okay, let's say we want to talk about a cyclic alkane. Okay, the structural form for that would be again Cn. Well, the formula to find out basically how many hydrogens you have based on your number of carbons would be CnH2n. And repeat, this formulas can be used to find out the number of hydrogens given a number of carbons. So if I was given 5 carbons again and it was a cyclic alkane, C5, it again would be H10. Okay, so we draw a structure of that. Cyclopentane is a nice good structure of that has the 5 carbons, 1, 2, 3, 4, 5, and it has the 10 hydrogens, 2, 4, 6, 8, 10. Remember, carbon has to have 4 bonds. Okay, so if we go to a cyclic alkene, okay, here we are with C5. I'm sorry, if we look at the formula first, the formula to find out the number of hydrogens given 5 carbons would be CnH2n minus 2. And again, sticking with the same thing with 5 carbons, we'll have 5 carbons. It'll be 5 times 2 is 10 minus 2, so we'll be at C5H8. Okay, 10 minus 2 is 8. And a good structure for that, for a cyclic alkene, hey, we know we got 5 carbons. We're talking about cyclic. We can't do anything right now but have a pentane ring and put the unsaturation there. Now we got a hydrogen there, got a hydrogen there. Okay, so that's two hydrogens here. Okay, always 2, 4, 6, 7, 8. Okay, each carbon must have 4 bonds. Can't repeat that enough. So given the difference between this, okay, this structure right here, acyclic alkane, has no rings, has no double bonds, and therefore has no degrees of unsaturation. Okay, so if no degrees of unsaturation here, can't stress that enough. No double bonds, no rings in this structure, so no degrees of unsaturation. In this structure, it has a degree of unsaturation. But that tells us that, and it's shown because we lost 2 hydrogens. We lost a hydrogen from this compared to this, and we lost hydrogen from this compared to that. So now we have a degree of unsaturation. Okay. Now from here, you see we also have the same formula here compared to that. No degrees of unsaturation here, but we lost 2 hydrogens, which means whenever you have a ring or a double bond, you have a degree of unsaturation. So degree of unsaturation can occur through 1 double bonds, 2 rings, 3, which is not shown here, but it can also be shown through a triple bond, because a triple bond is made up of 2 pi bonds and a sigma bond. Okay, so you have degrees of unsaturation there. You can have 2 degrees of unsaturation in a double bond. A triple bond. So this particular example gives you 2 degrees of unsaturation, which we're going to see here in a second. Going to go further into this triple bond thing. Okay, so now, given these examples here, I'm going to give you a formula. We're going to look at the things we talked about in class. Okay, we know how unsaturation is formed. I did not particularly mention rings and triple bond in class because I want you to get the concept of double bonds, but we're giving you the full lesson here. Okay, so let's say I gave you this formula here, C8H14, and you are to determine what is the molecular structure, or what are possible structures based on this formula. What are possible structures based on this formula? Okay, so we know we got. So now what I like to do is I like to see, hey, does it have any degrees of unsaturation in it? Well, to determine that, we look at this acyclic alkane here and compare it to this formula. If this particular molecule had no degrees of unsaturation in it, we would say it would be C8. We'll plug it into the acyclic alkane formula. It would be C8, and then it would be H 2 times this number plus 2, which would give us H18. Okay, well, this number and this number are different, so that means we must have some degrees of unsaturation. Okay, so 18 minus 14 equals 4, and we always find out degrees of unsaturation by taking this difference and dividing it by 2. So that gives us 2 degrees of unsaturation. Now this can be determined. Now, the way we arrive at 2 degrees of unsaturation, meaning that it can either have basically 2 double bonds, a double bond and a ring, or a triple bond, because triple bond results in 2 degrees of unsaturation by itself. So let's draw some structures based on this C8H14 formula with 2 degrees of unsaturation. Okay, so the first thing I like to always do, since we know it's an alkene, we can draw this basic structure here. We draw an alkene structure, so a straight chain, okay, acyclic alkene. So then we're going to have 8 carbons, CH3, CH2, CH2, and we must keep in mind while we're drawing this that we have to have 2 degrees of unsaturation. So I'm going to say CH double bond CH CH2, then I'm going to go CH double bond CH. Let's see, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's CH2. Okay, now I have my 2 degrees of unsaturation, 1 there and 1 there. So I have 3, 5, 7, 8, 9, 11, 12, 14 hydrogens. So it fits my formula. So this is one possible structure. Another way I can form a structure is if I can have a double bond and 1 ring, because that would also give me 2 degrees of unsaturation, which is what we're seeing. So I can do that by saying, hey, I have 8 carbons, so I can say 1, draw a cyclooctane ring, okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got my cyclooctane, and I know I got to have 2 degrees of unsaturation. So let me plug that in here. Well, 1 degree came from me making this ring. My second one is I just need to make a double bond. Okay, so that's H, and that's H. Okay, Okay, so now I need to count my carbons. Well, I mean my hydrogens. I know I'm gonna have 2 here, 4 here, 6, 8, 10, 12, 13, 14. So it fits this formula. Okay, it fits the C8H814 formula. One other way that could have been done, I want to show you something that's just unique, but this way is sufficient. You could have said okay, and then added a double bond there. Okay, so that gives me how many hydrogens? Okay, we still got 1, 2, 4, 6, 8, 9, 10, 11, 13, 12, 13, 14. Okay, let's count them again. 2, 4, 6, 8, 9, 11, 14. So it still works out, okay, to my formula. I just wanted to show you that little trick, because that's how you try to trick you sometime, okay? All right. Also could have 2 rings. We can also have 2 rings because one ring equals 1 degree of unsaturation. Okay, so let's look at this. Okay, so 2, 4, 6. Okay, 2, 4, 6. This carbon has 4 bonds already. 1, 2. I'll take that back. It has 3. 1, 2, 3. It has a hydrogen there, and you're gonna have a hydrogen there. Okay, I'm just gonna plug in all these so you easily be able to see them. I'm gonna have 2 here, or we can just count. All we gotta do now is count. But we know, since we have 8 carbons, we're gonna have the same number of, with these degrees on saturation, we got 2 rings. Okay, so let's look at this. Count our carbons. This is one carbon here at this joint. 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute, I did something wrong. 1, 2, 3. Oh, I have too many on this side. Forgive me. Yeah, I have too many on that side. So let me draw this over. Cancel that one. Okay, let's draw this one over. Slide up just a little bit. Okay, here it is. Okay, here we are here. Okay, we still gonna have a hydrogen here, so I'm gonna put that in so you can see it, and I'm gonna do my best. I didn't draw it big enough for it to be clear, but follow with me. Okay. Okay, now we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Okay, and we got 2, 4, 6, 7, 9, 11, 13, 14. So 2 double rings can fit. Now the last thing I want to show you is the triple bond example. Okay, all it is that we're gonna do a straight chain, CH3, and then I want to show you another trick. Instead of writing all those CH2s, we say CH2 and put a 5 out there. Okay, that means that we got 5. That means we got 5 more carbons. So now we got a total of 6, and then we say the 7th carbon, and then we put a triple bond, 1, 2, 3, yeah, and then put this carbon and put an H out here. Okay, now we got our 2 degrees on saturation with this pi bond, with this 2 pi bonds and a sigma bond, right? Each pi bond represents a degree of unsaturation. So we got our 8 carbons, 1 carbon, 6 carbons, 7, 8, and we got our 14 hydrogen, 1 hydrogen. 5 times 2 is 10 hydrogens, and then we got so that makes 11, and then we got 3 more makes our 14. Okay, so we have our 3 structures. We have all these different types of structures, and on the test I may ask you just 2 of them, or give me some possible structures. I'll at least ask for 2. So know that everyone should all be able to know how to do the straight chain, and know that 1 ring and a double bond gives you an unsaturation. So we're gonna do one more example of this, and we'll move to another thing. So if I gave you, and this is an example in class we did, Just won't hurt to just do it again. C10, H16. Okay, so I need to compare it to these formulas. First, I always go back to my acyclic alkane formula to see if there are any degrees of unsaturation. So degrees of unsaturation, it would be C10 times H 2 times 10, then it would be plus 2, right? For degrees of unsaturation, alkane, right there. There it is, right there. So now we have C10H22. C10H22, right? All right. So now what we need to do is determine the degrees of unsaturation. We'll determine degrees of unsaturation by subtracting this number from that number. So that'll be 22 minus 16 gives us what? 6. Gives us 6 divided by 2 equals 3 degrees of unsaturation. So we can either draw a structure with, we can have 3 double bonds, 2 double bonds, and a ring, or what would that be? A triple bond and a double bond. Okay, a triple bond, double bond. That gives us our 3. Any one of those. Well, I'm gonna stick to my favorite 2. Really, all of them doesn't matter. They're pretty simple, but we'll always start with the straight chain first. So C10H16, we got 3 degrees of unsaturation that we need to take care of. So what I'm gonna do is I'm gonna say CH3, and I'm gonna say CH, double bond CH, and now I'm gonna continue to go head on. I'm gonna put a triple bond here on the end to take care of this end. This say how many carbons I got? 1, 2, 3. Okay, got 3. I'm gonna say CH2 times what? 4. That'll give me how many carbons? That'll give me 4 carbons and 5, 6, 7. Okay, then I'm gonna say C, 1, 2, 3. C. So how many carbons I got now? I just need to get to 10. 1, 2, 3, 7, 8, 9, 10. Okay, that should take care of everything. Okay, remember carbon can only be bonded to 4 bonds. That's why you see these single lines here, not 2, or not bonded anything but 1 more. So we got our carbons taken care of, and this CH4. I just put that there to show you, make it easier for you. Okay, so how many hydrogens we got? We got 3. 4 times 2 is 8, so that's 11, 12, 13 plus 3 is 16. Okay, so we got our 16 carbons. So that's one structure. And I say give me 1 more. So from here you really can just go and put 2 double bonds in this same structure. I say CH3, C. Okay, then I say C, 1, 2, C. This have to be CH, CH. Here I say CH again. Okay, so that's 1, 2, 3 carbons. Okay, let me put CH2. Then we go with 4. Okay, same thing. So that's when they got 4 carbons. That's 4, 5, 6, 7. Okay, then we put another double bond here. CH, nothing but counting from here. Okay. Here. So that's 1, 2, 3. Then 4, 7, 8, 9, 10. CH3. So now I should also have my 16 if everything add up. Remember that carbon can only bond to 4 other bonds. So whenever much carbon, no matter what kind of structure you put, make sure each carbon only has 4 bonds. So that's C and 3, and then we connect to this carbon, that's 4. Okay, so that's 3 hydrogens. 4, 5, 4 times 2 is 8, is 14. I mean 13, 14, 15. Oh, I miscounted somewhere. Ooh, I miscounted somewhere. So that's 4, 5. 5 plus 8 is 13. 14. 15. Do I have 8 carbons? Let's see. Do I have 10 carbons? 1, 2, 3. 3, 4. That'll be 7, 8, 9, 10. Where did I mess up at? I don't see it yet. Let's see. 1, 2. Well, let's count the carbons. That's 4 plus 1, 4 plus 1, plus 8, plus 1, plus 1,